One major concept in statics is obviously the representation of forces. But the other one then is what the heck do we do with those, and that is all about equilibrium. And in the statics course, of course, that means that things aren't moving around, or at least they're not accelerating even if they are moving around. You see here a three-dimensional setting, and so in 3D, then if we're not accelerating in any direction, and in particular if the acceleration is zero, then we're going to end up having then some of the forces in the x direction being zero, some of the forces in the y direction equaling zero, and some of the forces in the z direction equal zero. So it's just a repeat of one of Newton's famous laws of F equals ma, where a is zero, and we end up then with three different scalar equations because we have three different directions that things could be moving in. These translational equations can be rewritten more simply in what I would call vector math terms as sum of the force vectors equal to zero, and that encompasses then the three translational equations. And likewise then we can also have three possible rotations, one about a rotation about each axis, and in that case then sum of moments about the x-axis equals zero, sum of moments about the y, and sum of moments about the z-axis, all of those equaling zero. And there again we can write a single vector equation that then would be sum of moments equaling zero. Okay. Now if you do that about a single point, you can get all three equations. If you instead do sum of moments about an axis, you might have to do three individual expressions, but symbolically we get then three rotation equations out of that. So two vector equations, but three scalar total number equations for a total of 6. And if we come back over to this crane with this applied force to the crane, where we now cut the cable that is going from A to B, then we expose that cable force T. It's a force in 3 dimensions, and then the equilibration that we end up with is that here at our reaction point we get 3 translational reactions, and we also get then 3 rotations for reactions. We have to have a total of 6 or we do not have equilibrium. Right? So big key there, 6 equations, and for statically determinate structures we need 6 reaction components that are independent.